4 soccer players, 3 tennis players, and 2 badminton players, and 1 swimmer sit on a round table with 10 seats. Find the number of possible sitting arrangements if the 2 badminton players sit together. So there are a total of 1, 2, there are a total of 10, 4 plus 3 plus 2 plus 1. Okay. So what we do is the 2 badminton players were to sit together. We can consider them as one unit lah. So badminton 1, badminton 2. Okay, around the round table, right? There will be how many people left? So maybe if I take away these 2, then 1, 2, 3, 4, 5, 6, 7, 8 people left. Total, there are a total of 9 units. Okay, because the badminton 1 and badminton 2 considered as 1. So total, if I want to arrange them, right, it will be 8 factorial. Okay, arranging 9 units around round table. On top of that, it can be B1, B2, it can be B2, B1. So times 2 factorial, and the answer will be 80640 ways. Alright, how about part 2? Part 2 is stated that we need the 2 badminton players to sit together, to sit directly opposite each other. So directly opposite each other, so what we can do, maybe we arrange the rest first. Okay, we arrange the rest first. Then we slot in the 2 badminton players later. Okay, you think about it. I arrange the rest. 1, 2, 3, 4, 5, 6, 7, 8. Right. So if one way is I want to put the badminton player, I can put here. Maybe put badminton player 1, badminton player 2. Okay. It can also be 2, 1, right? So each arrow you can see there's already 2 possibilities. So 2 possibilities. So one arrow, one way they can see opposite this way 2, another way is this way 3, another this way 4. Right, so there are 4 ways in which they can see opposite each other. They can also swap place, right? So it's 4 times 2. Alright. Then the rest, arranging the other people will just be, the red color crosses will be 7 factorial because there are 8 units, and the total answer comes out to be 40320 ways. Okay. How about for the 2 players sit together and none of the 4 soccer players sit next to either one of the 2 badminton players. Okay, the 2 badminton players sit together and none of the 4 soccer players sit next to either of the 2 badminton players. So what we can do is, again, we think about putting the 2 badminton players one side first. Okay, we think about putting the soccer players one side first. How many people do we have left? We are left with we are left with 4 people lor. Okay, so we sit down the 4 people. 1, 2, 3, 4. Okay. So one way to look at this, right, is because now there are a lot of restrictions. So if we try, for example, to take out the 2 badminton players, and then you put take out the soccer players as well, you're going to be left with 4 people only. So one approach to look at it is, for example, I can fix the 2 badminton players together. Okay, I'm going to choose 2 people from tennis and swimming. So these 2, right, you can see I have 3 tennis players and 1 swimmer. Right? I'm going to choose 2 of them, right? So this portion going to be like 4 choose 2. Okay, I'm going to put it as 1 unit. So I'll ensure that the badminton players do not sit beside the soccer players. So after that, I have soccer 1, soccer 2, soccer 3, soccer 4. I have another tennis. I have probably another 2, one from tennis and 1 from swimming. Alright. Then here, right, I'll make sure that, see, I have not put any soccer player next to the badminton because there's at least 1. Then what I do is I just consider them as 1 unit. 4 choose 2. So again, this portion here will be 4 choose 2. The fact that this here they can arrange among themselves, it will this possibility here, it can be B1 B2, can be B2 B1, so it can be 2 factorial. These 2 again can also swap, right? So it will be 2 factorial. Okay, then looking at the number of units, 1, 2, 3, 4, 5, 6, 7, number of ways to arrange will be 6 factorial. Right, so the answer comes out to be 17280. Okay, next one is for part 4. if the two people sitting beside the swimmer are from different sports, the two people sitting beside the swimmer are from different. So maybe what we do is we fix the swimmer first. Let's say we fix the swimmer, okay, and then you need another two people at the side. The two people sitting beside the swimmer. So if it's a swimmer, it could be that number one. Let's try to fix. It could be that this is from soccer. So if it's from soccer, it will be 4 choose 1. The other one could be from badminton. So it will be 2 choose 1. This is soccer. This one is badminton, correct? So now, any more cases? It could be also that the swimmer is here in the center. Alright, and what else could be here? Could be tennis, correct? So tennis, right? Say tennis. How many tennis will we have? There will be 3 choose 1. Okay? Could be soccer. Then it could be 4 choose 1. What other possibilities? Could be what else? Could be also swimming. The last one, and then it's between badminton and tennis, right? So badminton could be 3 choose 1. Tennis will be also 2 choose 1. Badminton and tennis and 3 choose 1. Alright. So after you've chosen them, you take note that the soccer, badminton, for example, you can swap. These two also can swap. These two also can swap. So taking into account 4 choose 1 times 3 choose 1. Okay, this one they can also swap among themselves. Taking into account 3 choose 1, all the different cases times 2 choose 1, they can also swap among themselves. Taking into account 4 choose 1 times 3 choose 1, times 2 choose 1, they can also swap among themselves. Alright, and after that, after we have all this, we need to consider that these three guys, right, whether the guys in the center, right, around a round table, there's going to be another 4, 5, 6, 7, 8, 9, 10. Right, so how many parties do we have? 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, so total of 8 units. So it will be 7 factorial, right? So here, coming back to this, we need to multiply this by 7 factorial. And the answer gives us 2, 6, 2, 0, 8 0 ways, right?